a WikiVidi documentaries production. Don't forget to like and subscribe. Enjoy. Donna Strickland. Donna Theo Strickland is a Canadian optical physicist and pioneer in the field of pulsed lasers. She was awarded the Nobel Prize in Physics in 2018, together with Gérard Mourou, for the invention of chirped pulse amplification. She is an associate professor at the University of Waterloo. She served as fellow, vice president, and president of the Optical Society, and is currently chair of their Presidential Advisory Committee. Early life and education. Strickland was born on the 27th of May 1959, in Guelph, Ontario, Canada, to Edith J., an English teacher, and Lloyd Strickland, an electrical engineer. She decided to attend McMaster University because its engineering physics program included lasers and electro-optics, areas of particular interest. At McMaster, she was one of 3 women in a class of 25. Strickland graduated with a Bachelor of Engineering degree in Engineering Physics in 1981. Strickland studied for her graduate degree in the Institute of Optics, receiving a PhD from the University of Rochester in 1989. She conducted her doctoral research at the Associated Laboratory for Laser Energetics, supervised by Gérard Mourou. Strickland and Mourou worked to develop an experimental setup that could raise the peak power of laser pulses, to overcome a limitation that when the maximum intensity of laser pulses reached gigawatts/cm2, the pulses severely damaged the amplifying part of the laser. Their 1985 technique of chirped pulse amplification stretched out each laser pulse both spectrally and in time before amplifying it, then compressed each pulse back to its original duration, generating ultra-short optical pulses of terawatt intensity. Using CPA let much smaller high-power laser systems be built, as tabletop terawatt lasers. The work received the 2018 Nobel Prize in Physics. Career. From 1988 to 1991, Strickland was a research associate at the National Research Council of Canada, where she worked with Paul Corkum in the ultra-fast phenomena section, which had the distinction at that time of having produced the most powerful short-pulse laser in the world. She worked in the laser division of Lawrence Livermore National Laboratory from 1991 to 1992, and joined the technical staff of Princeton's Advanced Technology Center for Photonics and Optoelectronic Materials in 1992. She joined the University of Waterloo in 1997 as an assistant professor. Strickland is currently an associate professor, leading an ultra-fast laser group that develops high-intensity laser systems for nonlinear optics investigations. She has described herself as a laser jock. Strickland's recent work has focused on pushing the boundaries of ultra-fast optical science to new wavelength ranges such as the mid-infrared and the ultraviolet, using techniques such as two-color or multi-frequency techniques, as well as Raman generation. She is also working on the role of high-power lasers in the microcrystalline lens of the human eye. During the process of micromachining of the eye lens to cure presbyopia, Strickland became a fellow of the Optical Society in 2008. She served as its vice president and president respectively in 2011 and 2013, and was a topical editor of its journal Optics Letters from 2004 to 2010. She is currently the chair of the Optical Society's Presidential Advisory Committee. Nobel Prize. On the 2nd of October 2018, Strickland was awarded the Nobel Prize in Physics for her work on chirped pulse amplification with her doctoral advisor Gérard Mourou. Arthur Ashkin received the other half of the prize for unrelated work on optical tweezers. Strickland and Mourou published their pioneering work, Compression of Amplified Chirped Optical Pulses, in 1985. While Strickland was still a doctoral student under Mourou, Strickland tried to put also the name of Steve Williamson on the paper, but he took it off as he hadn't done enough. Their invention of chirped pulse amplification for lasers at the Laboratory for Laser Energetics in Rochester led to the development of the field of high-intensity ultrashort pulses of light beams. Because the ultra-brief and ultra-sharp light beams are capable of making extremely precise cuts, the technique is used in laser micromachining, laser surgery, medicine, fundamental science studies, and other applications. It has enabled doctors to perform millions of corrective laser eye surgeries. Strickland said that after developing the technique they knew it would be a significant discovery. She is the third woman to win the Nobel Prize in Physics, and the first in 55 years, after Marie Curie in 1903 and Maria Goeppert-Mayer in 1963. On her receiving the Nobel, many commentators were surprised that she had not reached the rank of full professor. Strickland said that she has never applied for a professorship, and that it doesn't carry necessarily a pay raise. I never filled out the paperwork. I do what I want to do, and that wasn't worth doing. Brought to you by WikiVidi documentaries.